Welcome to our notes on graphing in intercept form. We'll also talk about in this video converting between standard and intercept form near the end of this. So if we're looking here at the very beginning, we are skipping over the warm-up and just jumping into the notes. It says graphing intercept form. So we see here our intercept form is y equals a times x minus p times x minus q. So why do we think it's called intercept form? Basically, it gives us our x-intercepts. It basically gives us the x-intercepts. Okay, so intercept form looks like it's a function that has already been factored, and that's pretty important. So we should be able to look at this and recognize that that A piece in the front here looks like it could possibly be a GCF, and then these two pieces inside the parentheses look like they have been factored either by busting the B or grouping or dots. So it's already been factored, which tells us a lot about the A, the P, and the Q. So let's talk about the A first. The A is going to indicate a couple different things for us. So first, A indicates that we have a vertical stretch. This means that the graph is going to be narrow, or a vertical shrink, which just means that our graph is going to be wider, and or possibly that we have a reflection across the x-axis. Now when we talk about the reflection across the x-axis, this is just talking about whether it's going to open up or whether it's going to open down. If it's opening down, it's been reflected. That's why we have a negative value in there for our A. Okay. Over on the right-hand side, P and Q, these are the x-intercepts of the function. So in order to get a 0 or x-intercept, we can substitute 0 in for the f of x or the y, and then we solve. So if we did this on this problem right here, if I put a 0 in place of the y, that would be this piece right here, then I would have 0 equals a times x minus p times x minus q. So if we have this, the way that we solved this in our previous unit was that we took each factor and we set it equal to 0. So if we set a equal to 0, we just get some number equals to 0, and that's not going to solve for anything. There's no x. But if I set x minus p equals to 0 and I solve for x, I add p to both sides. So notice I just get the positive of that value. Same thing with the x minus q. If I add q to both sides, I'm going to get that x is q. So we're really only concerned with this number. That negative sign there is telling us that it's going to be the opposite of what it looks like. So if we have something that has an x plus 2, when we solve it for x by setting it equal to 0, it's going to become a minus 2. And if it said minus 2, it's actually going to become positive 2. So let's just remind ourselves how to actually solve for an x-intercept. So remember, an x-intercept will always have a y value of 0. So what we're going to do is we're going to take this y and we're going to replace it with a 0. So 0 equals 2 times x minus 4 times x plus 3. Now it's in its factored form and it's equal to 0, so that means I can take each factor and set it equal to 0. So I'm going to take the 2 and set it equal to 0. That does not give us anything. Take the x minus 4, set it equal to 0, add 4 to both sides, we get a 4. Take the x plus 3 equals to 0, subtract 3 on both sides, and we get a negative 3. So what that tells me is that 4 and negative 3 are going to actually be my x-intercepts. So 4, 0, and negative 3, 0. Those are my x-intercepts. So let's compare those to our equation. Here it says a minus 4, and my x-intercept came out to be a positive 4. This one said a positive 3, and my x-intercept actually came out to be a negative 3. Okay? So let's see how that helps us when we actually try to graph this. All right, so we are graphing f of x equals 2 times x minus 1 times x plus 3. First question is, what are the x-intercepts? So remember, to find an x-intercept, we need the y to be 0. So I'm going to put a 0 in place of the y, or f of x. And then I'm going to set each one of those factors equal to 0. Well, when we set a 2 equal to 0, we don't get anything. Okay? When we set x minus 1 equals to 0, we're going to get a positive 1. And when we set x plus 3 equals to 0, we're going to get a negative 3. So that means our x-intercepts are 1, 0 and negative 3, 0. Again, if you take those and look in comparison, it started with a minus 1. When we set it equal to 0, it turned to a positive. Started with a positive 3. When we set it equal to 0, it turned to a negative 3. So we can go ahead and take these two and put them over on the graph. So I've got a 1, 0 and a negative 3, 0. Okay. So how could we find where the axis of symmetry will be? Well, the axis of symmetry, we said, is always exactly halfway. It's going to cut our parabola in half. So that means it needs to be exactly halfway between our two x-intercepts. So halfway between x-intercepts. So that means I can take my x-intercepts of 1 and negative 3, add them together, and divide it by 2. That's going to give me exactly where the halfway point is. So 1 plus a negative 3 is going to give us a negative 2 divided by 2, which gives us a negative 1. So our axis of symmetry is going to be at x equals negative 1. We could go ahead and draw that in here with a dotted line through the negative 1 value of the x. So then the next question is, well, how do we actually find our vertex? So we talked about our vertex. The x of our vertex is always going to be from the axis of symmetry. So I already know the x of my vertex is negative 1. So the question is, how do we find the y? So you can do this one of two ways. We can either plug this negative 1 into the original equation where the x's are, and then just type it into our calculator and get that number. Or we can type the function into the table on our calculator and look at the x value of negative 1. So the first way that I'm going to show you is just typing in to the calculator the original function with the negative 1 in its place. So what I'm going to type in the calculator is y equals 2 times negative 1 minus 1 times negative 1 plus 3. And I'm going to let the calculator do this. So I'm going to do it on the main screen, and I'm just going to type 2 times negative 1 minus 1, close the parentheses, open a new set, saying I'm multiplying negative 1 plus 3. And I'm going to let the calculator do the math, and it's going to tell me that this is a negative 8. So that means I could go over here and put my vertex at negative 1, negative 8. Okay, that's really good. I've got 3 points, but I always say you need to have 5 points. So I see I've got a vertex, I've got my x-intercepts, so if I can find my y-intercept, that would be probably the best thing. So in order to find a y-intercept, I'm going to draw myself a little space here. For y-intercepts, remember that the x is always the thing that is the 0. So if I can go back to my original equation and put a 0 in for the x's, like this, then that means I'll know the y value when x is 0. So again, we can type that right into our calculator. So 2 times 0 minus 1 times 0 plus 3, and it will tell us that our y-intercept is going to be at -6. So 0, -6. So that means right here. Now I still only have 4 points, but what's awesome, because I know that it's symmetric, I can come on the left side of the axis of symmetry and put that dot that it has symmetry with. Now I've got 5 nice dots, then I can draw my parabola a little bit easier than if I only had those 3. I've gone through all my important points: x-intercepts, y-intercepts, and my vertex. All right, so we're going to do the next one a little bit quicker. So my zeros are going to be the opposite of my P and Q. So I'm going to have a 4, 0 and a -2, 0. So that means over here at 4, 0 and here at -2, 0. My axis of symmetry should be halfway between them. So I'm going to take those, add them together, and divide by 2. So this is going to be 2 over 2, which is going to give me 1. So x equals 1. I'll go over here. This should look like it's going to be right in the middle. We can double check and say, hey, it's 3 from the left and 3 from the right. When we come back over here to do our vertex, remember the x of our vertex is going to be the axis of symmetry. Okay, this time I'm going to take my calculator and I'm going to use the table feature for those of you who are more comfortable with the table. So I'm going to type the function in. I'm going to use 0.5 instead of 1/2. Then I've got x minus 4 times x plus 2. And when I go to my table, this time I just want to go to where the x is 1. And it's going to tell me that this is going to be -4.5. Okay, so this is telling me it's not going to be a nice pretty whole number, but that's okay. So at 1, it's going to be down at -4.5. So that's going to be right here. The other piece I want to go and find now is that y-intercept, so I can get my 5 points. So that means I'm going to actually look on my table. I'll do the table on this one when x is 0. So just pull back up your table, arrow up to when x is 0, and you'll see that the y is -4. So that means at 0, -4, we have our y-intercept. So 0, -4, and then on the other side of the axis of symmetry, I can put the 5th dot. Now I can connect them, and I have my beautiful parabola. Okay. So take a second, go ahead, pause the video, work out the next one, and then come back. All right, here is that next one. You're going to see your zeros, your x-intercepts are at -2, 0, and at 3, 0. Your axis of symmetry should be at x equals 1/2 or 0.5. Your vertex is going to be at 0.5, 6.25. Your y-intercept will be at 0, 6. So that'll give you all 5 of the points that you need so you can make a nice parabola. Something that's different about this one is it opens down. You hopefully noticed that by the negative in the front as you were working on it. Okay, so down here at the bottom it says, what can we tell about a parabola when it's written in intercept form? Well, the x-intercepts occur at P and Q. The axis of symmetry is going to be P plus Q divided by 2. And your vertex, you can plug in what that value that you got for the axis of symmetry as your x and solve for your y. Okay, you can use the table for that, or you can actually solve. Okay. Then underneath that here, we have, it says write an equation in intercept form for the following parabola. So what we really need is we need to know where our x-intercepts are. So this one is at -3, this one's at 1. So when we put that in, we need to use the opposite sign. So the opposite of -3 would actually be our +3. And then the opposite for our +1 would be a -1. So this would be good enough for that. I'm going to do as part 2 to do the converting between our standard form and intercept form.